Okay, we are live.
Hi everyone, how are we doing today? Welcome to today's series on Azure AZ-104. On today's episode, we are going to be discussing a topic called Azure Intersite Connectivity. My name is Catherine. I'm going to be your moderator for today. We are having Kofi Adi. Kofi Adi is a technical account manager and also an ACT with over 10 years experience working in the IT industry. Hi, Kofi.
Oh, hi, Katrina. Hi, everyone. I'm glad you've taken your time to join today's session. I know we have multiple sessions over the course of the month, and today finally we are at administering the Intersite connection between Azure services and also Azure network. So I hope you are excited to be part of today's session. So without any further ado, I think I'll probably will get started and we'll go through today's event. So let's start. All right. So what we're going to look into today is that we're going to look into how to configure Vnet peering, and also we're looking into VPN gateways and ExpressRoute. So when it comes to Azure Inter connectivity, there are multiple ways to connect services on Azure. Connect your resources like network on Azure. This range from Vnet connections from your, let's say, local on-prem network to the Azure, or probably you want to connect services or resources on your cloud. Let's say a Vnet to a Vnet. So all of these, you have to use a way to address those sort of ways of connection. And one of the ways to do this is using the Vnet peering. Then we can also go into a bit further by saying if you want to connect your on-prem to the cloud, so then you probably have to rely on a VPN gateway, or you can also use what we call the ExpressRoute to do the connectivity. We also look into virtual WAN connection. So this is more like creating something similar to a hub and a spoke, where you have multiple hubs in different regions, and then your VPNs, your ExpressRoute, and let's say your peering, all of them can seamlessly connect to each other using the virtual WAN service for this. So we're going to look into all these things here today. So I drew this diagram just to depict exactly what we're going to go through. Just like I explained earlier, you have a specific type of connections or tools per se that will allow you to establish connection from your on-prem to, let me just bring up the laser. So you have a connection from, let's say, your on-prem to the cloud, which is Azure cloud. So you can use ExpressRoute for that connectivity. At the same time, you can also leverage on VPN gateway for that type of connectivity. And inside your Azure infrastructure, you can leverage on peering to establish connection between a virtual network and another virtual network. So you literally can have multiple virtual network, all of them connected to each other using peering. You can also leverage on the VPN gateway to establish the same connections as well if you choose to. But for high bandwidth wise, I think it would be recommended to use the peering, because that relies on the Microsoft backbone network, which is much more efficient, and also in terms of latency wise is much better. All right, so let's move on to the next. So we start with the Vnet peering. Okay, so what we're going to look into here will be describing what a Vnet peering is, telling you about some of the benefit of Vnet peering, and also creating the Vnet peering as well. Right, so what is Azure Vnet peering? When it comes to Azure Vnet, by default, devices or subnet within a single Vnet can talk to each other And outbound internet traffic is also allowed by default, but individual VNet are isolated from each other. So in order to allow two or more virtual networks to communicate with each other, we need to set up VNet peering. This will allow traffic to easily flow between two or more networks. It also allows us to bridge together our virtual networks so that we have the connectivity between these networks using peering connection that we set up. So now there is something a bit more important that you have to consider when it comes to VNet peering. VNet peering are non-reciprocal. What this means is that when you establish connection, right, you need to make sure that the connections on each side, you set up the connection on both sides. So literally, as you can see on the screen here, when I set up the VNet peering here, I need to also set up a VNet peering there to allow the communication to work. You cannot just set up the VNet peering on one network and then leave the other network. It won't work. They need to be set up that way to allow the communication. So there are two types of peering. We do have what we have a peering when it's between two network within the same region, and this is called the regional VNet peering. And we can also have a connection whereby there is a VNet in one region and another VNet in another region, and we set up a peering between them. That is what we call global peering, as you can see on the screen here. So as depicted on the screen, there is region 1 and region 2. And when we establish a VNet peering between these two, we have the global peering. But in an instance whereby those VNet are within the same region, then it becomes regional VNet peering. And so this is something that you have to think about when you are establishing these connections. The key point is this, right? VNet peering actually relies on the Microsoft backbone network. So the traffic doesn't traverse over the public internet. And Microsoft have, they have a lot of, let's say, edge networks or edge location around the world. So they have the power and the capacity to really have those traffic less moving around just their own infrastructure without even touching the public internet. So we could have several different regions connected using virtual network peering connection. Another thing that we have to keep in mind with VNet peering is that they are non-transitive. And what I mean by this is that, say we have a peering connection between VNet 1 and VNet 2, and one going in the opposite direction to, let's say, VNet 2 to VNet 1. These virtual networks are paired, and let's say that VNet 2 is also paired to VNet 3 here. So as you can see here, VNet 2 connected to VNet 1, and then at the same time, VNet 2 is connected to VNet 3. So in this case, what will happen is that this VNet can talk to that VNet here, and the VNet 2 can also talk to VNet 1. But what is not allowed is that just because VNet 1 is have a peer connection between this and that, it doesn't mean that VNet 1 can send traffic through VNet 2 to VNet 3. That's not going to happen. So it's non-transitive. So that means it's not going to allow that level of traffic to flow through. For that traffic, for VNet 1 to talk to VNet 3, what we need is, let me just bring up a pen. We need to set up another connection between those two networks to allow that connection to happen. That's something that you should definitely bear in mind when you're using a solution like VNet peering. If you want the transitive sort of connectivity, then you need to think about a different solution. We will come to that momentarily. Right. We have to create a separate peering between those two, like I said, to allow those connections to work. So from here, what I'm going to do is I'm just going to bring up the portal, just go through how to set up the a Vnet peering. So let me just bring up the portal momentarily. Okay, so this is my Azure portal. Now, I've already prepared a few network for this session. So I created a demo net and demo net 1 and also demo 2 net. And currently, these two networks do not talk to each other. And we can go straight to the machines in these network because I have created a machine in this network here. So if I go into it and go to connected device, you see that there is already an existing network interface with an IP address here. And equally, if I go to demo 2 net, there is also another interface here, which is 10.0.0.4, right? And these two networks cannot talk to each other. So to prove that, let me quickly bring up, actually, let me go to the virtual machine session so you can see those machines. So those are the two machines they're currently running. So I'm just going to click on demo 1 VM1, and I've already connected to it. So as you can see, the private IP address for this one is, let me just bring that up. The private IP address is 10.2.0.4. So I've already RDP into this. So here we have it here. So if I check the IP address, so host name and it's I. So as you can see, 10.2.0.4, and that's the same IP address here. All right. And the other device, let me bring that also on the screen. Okay, so this is the other device as well. So if I type in hostname -I, the other device is 10.0.0.4. If I attempt to pin this one here, let me just copy that and try to pin it. It's not going to work because there is no connection between those two. All right. So what we're going to do is we're just going to set up a peering between these two, which will allow the traffic to flow between them. So let's go back to the portal. And to do this, what we can do is we can leverage on peering, like I said earlier. So we will need to go into the networking part. So if I go back and then select virtual network, and then select one of these network I want to create a peering for, under the blade, the settings blade, there should be an option for peering. So as you can see right here, so all I have to do is just select peering and then click on add. And I can give it a peering name. So what I'm going to do is I'm just going to name it demo 1 net to demo 2 net. So as you can see here, the traffic will allow the flow of the traffic. You can block it if you want to, but we want to allow the flow of the traffic, so we can leave it as it is. And then we can set up the remote side as well. So I'm just going to give the remote side a name. So I'll change it, this one from demo 2 net to demo 1 net. Because what I'm doing here is that I'm creating a network in both directions. The first one is creating a network, as you can see here, is for the first Vnet 1 to the Vnet 2. And the second blade is for creating from Vnet 2 to then Vnet 1. Right. So once you've done that, I will have to then select the network I want to use in this purpose that I want to connect to. So I'll drop this one down and then select the demo 2 net, which will allow the traffic to flow from Vnet 1net, then to demo 2 net. All I have to do is all done. I just have to click on add. It will take a bit of minutes to complete, but I think it will take that long. So let's give it a few minutes. And we do have the refresh button here. So every now and then we can just hit the refresh button just to see whether the service has been established. So once this connection changed from update to connected, then we can now, here you go. So we have it connected now. So if you bring back our network here and try the pin again. So as you can see, we can now pin this IP address because we've created a peering to allow the connection to happen. So that's it. Once we create a peering, you notice that another thing you will notice is that the peering created here will also automatically be deployed here as well. So both of them will have the peering and it will set up as connected. Okay. So what I'm going to do is I'm just going to put a link in the chat window so you can follow through if you wish to set up your own peering. So I'm just going to paste in the chat window now. Okay, so let's go back to the slides. So now let's look at the benefit of peering. So with Vnet peering, you have cross-network communication. That means by default, since when you create a Vnet and another Vnet in the same region or even in a different region, there will not be the option for them to communicate, but leveraging on the Vnet peering, that communication become possible. And another benefit is that it's low latency and high bandwidth because it leverages on the Azure backbone, network backbone, and have high speed and high bandwidth. And also data transferred between and across tenants via Azure roles, subscription, and also Azure region. So in an option where you create your Vnet peering, you have the option to select even a subscription base. For example, you might have a partner company or organization that you work with that you want to connect to their network. You can use their subscription to establish the same Vnet peering, because if they're not part of your own subscription, then you can get their subscription and then use that one to establish the Vnet connection. And also the last one is that no downtime to resource in either virtual network during the creation process. So during the creation of the Vnet, as you saw earlier, nothing was affected. None of my network or devices in the network was actually impacted by it. It was just as simple of selecting the options and saving it. And then once the network connection was established, I can pin across easily. Okay, so like I said, I've shared a link in the chat window, and you can use that one to set up your own Vnet peering. So let's move on to VPN gateway. Right. So with VPN gateway, what we're going to look into is that we're going to look into the VPN gateway to you do the comparison between the VPN gateway and the peering as well. So this lesson, implementing VPN, where we are going to start off by comparing the VPN gateway to Vnet peering, so that we understand the times in which we could choose VPN gateway or Vnet peering. And when we are, one other thing we're going to talk about is the capabilities of these services. Another thing is all about considering connection from, let's say, your on-prem environment, which is the hybrid network, when you have some resources on your on-prem and other resources on your cloud. You can leverage on the VPN gateway to establish that. We are also going to talk about routing types that we have with our VPN gateway and the VPN gateway skills as well and their capabilities. And then we are going to talk about the active, and the active passive configuration for those VPN gateways as well. So the higher availability options that we have. After this, we'll go through the demonstration of implementing the VPN gateway inside Azure portal. So what is VPN gateway? In Azure, VPN gateway has the same purpose as a peering connection using Vnet peering. What we want to do is we want to make hybrid network. Our on-premise network are allowed to communicate in the same way that we do with virtual network peering inside our Vnet, except for this time, we are leveraging on the VPN gateway. VPN gateway are going to allow us to connect to different networks, both on Azure network and also our networks within our on-prem network, from our on-prem network to Azure as well. All right, but another key point is that with connection between VPN gateway and Azure, it will go over the public internet, but the traffic will be encrypted in the tunnel. But when you want to create the VPN gateway, a special subnet called the gateway subnet is required in the virtual network. And each of these virtual network gateway are going to have a public IP address because, again, this is going to be over the public internet in terms of the communication, leveraging on IPsec tunnel with the traffic being encrypted. So if for whatever reason this traffic is captured and someone tried to obviously decrypt it, those traffic become more like it won't make any sense to the person because those traffic are in the tunnel and they are encrypted as well. So when you intercept it and capture it, it becomes extremely difficult for you to really exploit it. One common question that people ask is, what should we use VPN gateway over Vnet? Because if Vnet goes over the Azure backbone and have high speed, why do you want us to then use a VPN gateway which go over the public internet and probably the speed are not as good? The reason is going to be the capabilities that the VPN gateway provides us. It's establishing these point-to-site VPN gateway and also site-to-site VPN gateway. So you can have an application on your device, on your mobile phone, and then it can instantly be established connection to resources in the cloud, leveraging on the VPN gateway. And in terms of site-to-site, you have your on-prem or your branch office, and you want those devices in those branch office to have access to resources in your cloud, then you can leverage on that. Peering, on the other hand, is more like traffic within the Azure environment. You cannot have a peering from on-prem network to the cloud. In that scenario, you have to leverage on either VPN gateway or ExpressRoute in that for that matter. Another thing that makes VPN gateways different from peering is that our peering is that there is a transitive nature aspect of it. Because as you mentioned, when I was looking into the peering, one of the key elements that it was lacking is that it's non-transitive. But when it comes to VPN, you can have the transitive nature. So that means you can have a connection going through another gateway to another network. That is possible. All right. Okay, so there are two types of VPN gateway routing. We have the policy-based routing and also the route-based routing as well. So with a policy-based routing, This allows static routing via policy declaration that we make. And this means that inside of our network, where things are constantly changing, we have to statically update these routes. We also have to support for on-prem legacy. So with the policy base, it support the IKE version 1 encryption, and we can only use the basic SKU on this type of policy-based routing. But with route-based routing, what we have here is static and also dynamic routing. So in the case of which we have an environment that is constantly changing, you might use a route-based dynamically routing because it is resilient to topology changes and even an ever-changing environment. Now, with route-based, we have the ability to coexist with ExpressRoute as well. Many companies leverage on that. They might have two connections. There'll be the primary connection will be ExpressRoute, which will have high bandwidth, more like the dedicated line. But just in case anything happened to it, then they can actually fall back onto using the VPN gateway, obviously leveraging on the route based solution. So now let's look at the process of creating of a VPN gateway. So first off, we need to create a gateway subnet. Let me just get the laser. You create a gateway subnet. Once you create a gateway subnet, then we have to create the VPN gateway. Then we will create a local network gateway. This will be the IP address or the FQDN of our on-prem edge device, which we're going to use in terms of the creation of the VPN. Then we'll move to our on-prem, and then we'll configure the same settings we've done here on our on-prem. And then we'll create the VPN connection to establish those connections. Okay, so what we're going to do is we're just going to run through a bit of demonstration of how to set this up. So first off, like I said, we will create a subnet. So with a subnet, it will have a special name. You need to ensure that then you name it gateway subnet. If not, it's not going to work. You have to have that specific name for the VPN gateway to detect it. So you set it a name, and then you follow through the settings. Once you're done, then you go to the blade where you set up the VPN gateway. And through the process, you will have the option of selecting the virtual network. And if you have not created the gateway subnet, you will not be able to select it. So it's very important that the first option, the first part, you create the gateway subnet as implied. Once you've created a VPN gateway, then you can create your local gateway as well. So let me just go back. So you create your local gateway and then it will work. But another key point is the SKU. So the SKU here will have different level of bandwidth that you can get based on the SKU you select here. So now let's look at the different subnet you get. So with VPN JW1, you get a maximum of 30 tunnels, and for site to site, and for point to site, you can get a maximum of 250, and the throughput is about 650 megabits per second. So as you can see from here, when you're going down the chain, the more bandwidth you get. You can get an upwards of 10 megabits per second, gigabits per second when you select the VPN Gateway 5 option. Right. So let's move on to the next page. So once you've created your VPN gateway, then you go to the next option of creating your local network gateway. This, like I said earlier, will be your on-prem network. So that will means you need to enter the IP address of your VPN concentrator at your on-prem network. You can also leverage on the FQDN and add a fully qualified domain name for your VPN concentrator if needed as well. Once you have this one created and also the VPN gateway created, then the next part is creating your connection, and that will establish the connection and the VPN will start to work. So these are some of the VPN devices that support connection to Azure VPN gateway. We have popular names like Barracuda, Cisco, Citrix, Jupiter, F5, Palo Alto as well. Okay, so like I said, the moment you finish creation of your local gateway and also your VPN gateway, then you move to the option of adding those connections, combining them together with a pre-share key. So the pre-share key you use here should be the same used on your on-prem VPN concentrator as well to allow the connection to establish. And for the type, you select type to site VPN, or if those traffic is actually within the Azure network. So for example, if you're leveraging on VPN gateway to connect to Vnet on your Azure environment, then you can select there'll be another option for Vnet to Vnet. You can select that option as well. So, but in this case, connection was to our on-prem environment. So then we can select the connection type as site to site. Now let's talk about the high availability scenarios that we have. So we have active, passive, and also active scenario here. So with VPN gateway, we have the option to use either the active or the active passive configuration. So let's say we have a Vnet gateway here, and we have a Vnet connection between an on-prem network. What is going to happen here in a traditional method is that you have a connection that will have active. But in doing so, that means if one network goes down, the other will take over, and vice versa. So the key point here is that it creates that atmosphere whereby you're always having a network that is connected. If anything happens, then you are rest assured that there will be another redundancy that will take precedent, and then will allow the connection to continue to function. You also have the ability to create the active standby scenario, whereby actually the active standby scenario is actually the default, but in a sense that whereby you have a connection established, one will remain dormant, but there will be a keep alive probe constantly checking to ensure that those connections are alive. If one goes down, then the other will take over. Okay, so equally, what I'm going to do is I'm just going to share with you a link that you can use to configure a VPN gateway in a chat window. So let me just share that with you momentarily. Okay, there you go. So moving on to the next lesson, we're going to look into configuring ExpressRoute, and we'll further move on to creation of a virtual WAN as well. So in this lesson, we're going to look into ExpressRoute uses, ExpressRoute capabilities, and how site-to-site and ExpressRoute coexist, and compare Intersite connection options. And then we move on to the virtual WAN usage, and then we run out and talk about this, the summary aspect of the whole session for today. Right, so ExpressRoute. So what is ExpressRoute? ExpressRoute is a service that lets you extend your on-prem network into Microsoft Cloud over a private connection with the help of connectivity provider. So the key point here is private connectivity, because with this one, instead of obviously just passing traffic over the internet, like using of the VPN gateway, this you have to work with a private connectivity provider like an ISP, and then you have the dedicated line to their edge location, and then once the edge location is established, then they'll connect directly to Microsoft Edge locations as well for that connection to work. So with ExpressRoute, you can establish connection to Microsoft Cloud services such as Microsoft Azure and also Microsoft 365. ExpressRoute connections don't go over the public internet, like I said earlier. This allows ExpressRoute connection to offer more reliability, fast speed, consistent latency, and high security than typical connection over the internet. Now, how this is different from VPN gateway is that with VPN gateway, you don't get the dedicated physical connection. All right. The connection is not encrypted by default, but you can obviously go to that extent as well. So with this, it allowed that private connection over the wire to the Azure cloud. And then we can access our Azure resources from our on-prem network. So using ExpressRoute on our on-prem resources, and it will allow users to access those infrastructure we have on the cloud, both virtual networks or virtual machines and other Microsoft resources like Office 365. And this includes things like SharePoint Online, Exchange Online, and other platform as a service resources on Azure. We can do this using what is known as edge locations on the Microsoft side of things, and on-prem side, we have the partner edge locations. So we can utilize a partner like an ISP to allow us to connect from our on-prem network to the Azure edge location. We create ExpressRoute circuit. We have both a primary and also a secondary circuit. This exists between the Microsoft Edge and the partner edge, allowing for highly available connections on two physically dedicated connections into the Azure resources and Microsoft resources that we have. And then we can connect through our partner to our on-prem network, allowing us to connect from an on-prem network to the edge network. So once that circuit is built up, then we can easily access those resources. And another thing we can leverage on is that we can leverage on utilizing the VPN as a backup line. So our ExpressRoute will be the dedicated, more stable connections. But in case of any issues with that connection, we can then fall back onto the virtual, the VPN gateway for that matter. Okay, so built into the ExpressRoute is redundancy. The ExpressRoute is more like, in a way, it's built in a way that it always want to provide the highest level of connection possible and leverage on any kind of redundancy. So inside of the connection is a built-in redundancy because we have primary and also the secondary connection with ExpressRoute that gives us the connectivity to Microsoft via the partner edge network to the Microsoft Edge. And we have connectivity via the private peering, like what we tried to the private edge, right? So mostly with these type of connections, always you need to think about that Microsoft service might use what we call the BGP in terms of these connections. So on the on-prem side, one of the key points is that you need to always think about that if you are working with an ISP, that will be one of the solutions or they will be considering. And in terms of the bandwidth, you have bandwidth from, let's say, 50 megabits per second to about 100 megabits per second. So it's high speed, dedicated connections when leveraging on using ExpressRoute. So as you can see from this image here, this is what I was explaining earlier in terms of leveraging site-to-site and also ExpressRoute together. So you can have ExpressRoute as the primary connections connecting your on-prem to Azure. But at the same time, you have the VPN gateway as the more like a backup line, or even use it to connect to other locations that do not leverage ExpressRoute. So, for example, you might have a second site or a branch office that also want to have access to resources in the cloud, but you don't want to spend extra money because the sister site might probably not be a place where require that dedicated line. So you might then use VPN gateway for that matter. So that means you're using different intersite connectivity solutions to really address a problem you might have in your environment. Even in certain scenarios, you might be leveraging on multiple intersite connectivity in that matter. Right, so comparing the site connection options. All right, so looking at the virtual network point to site, right? In terms of the supported service, more like infrastructure as a service, like virtual machines, right? And it's leverage it's based on the on SKU. And in this scenario, you can have active, passive, and the type of usage is more like in the dev, test, and also labs environment as well. And looking at site to site, similarly, this one also infrastructure as a service, and then this will give you much more bandwidth and give you two options of active, and also active passive as well. And equally, you can leverage this one dev, test, and also lab environment. And you can also use it for a small scale production workload and virtual networks. But ExpressRoute is the main key point when it comes to enterprise level. When it comes to enterprise level, you always want to ensure that they're highly available, highly redundant. So leveraging on ExpressRoute will actually help in this kind of scenario. So as you can see here, this will provide you enterprise class and mission critical workload big data solution. And in terms of the bandwidth, it's extremely high, from 50 megabits per second to 100 gigabits per second. Now let's look at Virtual WAN. So with Virtual WAN, also referred to as Azure WAN, what we have is a network service that allows us to have a single operation interface to be able to manage hub and spoke style network and a fully managed network inside of our Azure cloud. We use Virtual WAN Hub to create the hub and spoke style network, where we do things like have our virtual network for a site to site and also point to site, or for both on our on-prem and also remote users. We can also connect our ExpressRoute on-prem connections as well as make connection to our virtual network inside the hub. And with these one, so essentially, this is more like a key point in our network where we have multiple connections. Like we have VPNs, we have ExpressRoute, we have site to site, we have Vnet to Vnet connection peering. All of these, you need a way to ensure that all of them can actually talk to each other. That's when you leverage on the virtual WAN, because the virtual WAN will bring all these components to be able to talk to each other. But bear in mind that in terms of setting up a virtual WAN, there will be one hop per region. So if you have resources on multiple regions in the cloud, you need to have one hop in every single region to allow these connections to really flow, or these services to really talk to each other. Right. So that's one of the key points that you need to think about when you are setting up these virtual networks. All right. And also there are two SKUs. There is the standard, the standard and also the basic as well. The basic only allow IPsec, but if you want to get more, then you need to use the standard, which will leverage on ExpressRoute, site to site, and what have you. So the key thing is that when it comes to production, it's always key that you switch to the standard SKU for this purpose. Okay, so that's all we have for today's session. So what I'm going to do is I'm just going to share with you how to create ExpressRoute and also virtual WAN. I'm just going to paste a link in a chat window, which you can follow. Okay, so this is what we have for today's session. I'm just trying to check to see if there's any questions in the chat. So far, I don't see any questions yet. Okay, yep. So just trying to check to see if there's any questions in the chat, but I can't see any so far. Okay, so if there's no questions, then we'll call it a day. So thank you for joining today's session, and I hope you find this informative, and then you'll be able to actually follow through with the links I've provided. If you do have any questions, but do well to reach out to us through our community, through probably LinkedIn or Twitter. We will share our handle as well. So thank you for joining today's session. I hope to see you again on our next series, which is next week, same time. Thank you for your time and enjoy the rest of your day. Bye for now.